Okay, welcome back to AS123. This is our third week, and today there is a great variety of topics. One thing I would like to cover today is installing code blocks, because I think you need a good solid platform to be able to work with, experiment with code, and we're going to search for code blocks. Okay, I'd like to start with this, code blocks, and we can just search for that or Google for that. Right, so code blocks is, as you can see here, is an open source, cross-platform, free, integrated development environment. This is what IDE stands for, Integrated Development Environment. It has lots of fancy things, most of which we won't be using, but I would encourage you to install it. And I'm going to install it myself right now. What I do, I click on downloads here, and you can probably find a lot of like YouTube videos and other resources which would tell you exactly step by step what we're doing here. So today I'm just briefly going to do this. The easiest way to install it is this first choice under download section. You can try it on these computers right here, okay? And you have different platforms. Again, I won't go into any details. Right here I have Windows 7 system, so I'll just go to this. And what I'm going to install is this option, as it says in the comments. This specific option right here allows you to download the integrated development environment and also a compiler bundled with this install. And this is what I'm planning to do. I don't think that Berlioz works. I think we need to click on SourceForge. This is where I'm going usually when I install things. Right. So as usual, it should tell us that it's going to start download shortly. After it gives us a chance to look at these ads. So it's an executable module which we have to download, and I'm going to download this. Okay, so right there it says it's going to take a while for me to download, so it's altogether 97 megabytes or 98 megabytes of stuff. Obviously, whatever our broadband permits, we're just going to let it run. In the meanwhile, I'm going to switch over to, so I'll wait for this to finish, and in the meanwhile, I'll just jump to CIS-123 homepage. Today is week 3, and we're definitely going to start looking at pointers, which are essentially a set of methodology to utilize direct access to computer memory. Okay, but we have some left over from week 2, and I'm just going to click on week 2. We still have our quiz as our first homework assignment, but I'm going to post the next quiz later this week. So we're going to have already 2 quizzes out there, but we still have a great deal to cover before we will be ready to take that second quiz. All right, so I would like to open this presentation for procedural programming. And since we covered aspects of procedural programming very informally last week, today let's just go over some of these ideas that are part of this specific presentation. And of course, the chapters of the book are available here for you to read, so please, I'm not going to remind you every week that you should be reading those pages. In fact, if you're reading them or just follow the presentations and research things online, you should still keep looking at, you should probably have a list of questions, and you should bring your questions to class, and we should always discuss them and give you answers. All right, so this is my view of something that's called structured programming. Another name for it is procedural programming. So this is a classic and traditional approach which still works pretty well. For instance, pretty much most of operating systems today are written using C, and it's a structured programming approach. So if you think about a program to write, like for instance here, maybe I'm thinking about a program that works like a blackjack game or something like that, a card game in general. I can think of two things specific to program organization. One set of things to look at is a list of actions, right? Like shuffle the deck, deal a card, or maybe deal to a specific hand, place a bet, use commands during betting process like hit and stand, and so forth, and so forth. And on the other side, so these things look a little bit like verbs or action words, right? On the other side, there are things that look like objects or concrete sets of data or some concepts. For example, what's a card, right? So we have like a, maybe to deal with 36, 32, 56 deck of cards. What's a suit? What's a deck of cards? What's a bank? What's hand? What's score? Dealer, player, and other. In other words, to say perhaps, just a single word for this category is an object. An object is a piece of data, well-structured, well-defined set of information which can be generally referred to by a word that looks more like a noun, right? So we have actions and objects. And when you think about it, then you can begin to say, oh, shuffle a deck. That makes sense. So you can say, you can put a check mark here or cross the field like that, and even make a little note in there to say, I'd like to remember that these things really interact. So essentially, the plan is to convert these actions into a set of functions in C, or set of methods in Java, if Java is your programming platforms. And of course, these noun words will become individual variables or maybe more complicated objects, such as player, right? Player right here may have, maybe a skill level, the nickname, current score, perhaps, and whatever their current situation is in the game, right? So we can leverage that later on. So these are things that we really kind of do deal with in the structured programming approach. This is very simple, right? Just essentially cross-mark what's out there, list things, and essentially try to envision how complicated the challenge is. Okay, so let's move on, see what this outline here tells us. Okay, so software design and implementation. So classic approach to doing things is go through a stage of design where we essentially grab a piece of scrap paper and try to decide what should our program include, what should it do, what features. So everything begins with an idea, right? So we go to a drawing board, begin to develop our vocabulary to say what are good words, terms that describe the challenge are in the so-called business domain, right? What features we would like to include, how sophisticated the user interface is going to be, what components we want. And in terms of components, we're going to use variables and functions.